Okay, hello again everyone. So in the last video we learned what the row echelon form is, reduced row echelon form is. So starting from this video we are going to solve bunch of examples. Okay, so here's the example problem that I have a linear system of equations. I'm going to first write the augmented matrix, do the row operations and get the row echelon form, and then I'll show you how to get the reduced row echelon form and get the final solution. Okay, a solution exists. Right, so first we need to write the augmented matrix. That I'm gonna do by extracting the first coefficients. So the coefficients of the first row is 1 for x1, no x2, so 0, minus 3 for x3, and the right hand side is 8. So likewise, second row, the coefficients are 2, 2, 9, the right hand side is 7. And on the third row, no x1, so 0, x2, 1, x3 is 5, and the right hand side is negative 2. Okay, right. So now what I'm going to do is I'm going to apply the row operation. So let me rewrite the augmented matrix. 1, 0, negative 3, 2, 2, 9, 0, 1, 5, 8, 7, negative 2. Okay, so what row operation should we do? What should be on our mind? We want to create the triangle of zeros, right? Under, below the diagonal. So here we need to make these three 0. Or now we know we want the row echelon form. To get the row echelon form, what we need is, so we identify the first leading entry, and this is the first leading entry in the first row, the first non-zero number. Under that, everything should be 0. Okay, so that's what we want, right? So to make that means we need to make 2 0. Okay, so how can we make 2 0? Well, we can multiply the first row by negative 2 and add it to the third row. So negative 2 times row 1 plus row 2, right? Okay, then negative 2 plus 2 is 0. So first row doesn't change. 1, 0, negative 3, 8. Second row here 0. 0 times negative 2 is 0. So 0 plus 2 is here. It's going to be 2. Negative 3 times negative 2 is 6. 6 plus 9 is 15. Okay, and 8 times negative 2 is negative 16. Negative 16 plus 9 is negative 9. This is 15. Okay, that's what we have for the second row. Right, now we look at the other end. So we need 0 here also. Now we already have 0, right? So that's convenient. We don't need to worry about that. Okay, so now we go to the second row, because under the first leading entry, okay, everything under first leading entry is 0. Right, now we go to the second row. In the second row, the leading entry is now 2. And now we are on the right path, because a leading entry should be to the right to the previous leading entry. So here's the first leading entry, and the second leading entry is on the right hand side, on the right side to the first leading entry. So good, the previous leading entry. So we are on the right track. So everything under leading entry in that column should be 0, right? So this 1 should be 0. How can we make that happen? Well, here's something we can do. I can take the second row and divide it by 2, then this will become 1, or divide by negative 2, so that will become negative 1, and add it to the third row, right? However, there's an easier way. Okay, so if you do that, if you do the thing that I said, so like divide by negative 2 and add, then we are going to deal with fractions here. Here's the easy way. I am going to swap row 2 and row 3. I'll show you why. Okay, so remember, swapping rows is something that you can do, allowed as row operations. 1, 0, negative 3, 8, 0. I'm going to swap row 3 and row 2. 0, 1, 5, negative 2, 0, 2, 15, negative 9. Now, why did I do that? Well, now you can see I don't need any division. That's the key. If possible, I would try to avoid division when you are doing row operations. Okay, because divisions, if you create fractions, it's an additional algebraic burden. Okay, it's prone to more errors. Okay, simplification errors. But here now I can do is I would rather do one extra operation like swapping here if it's avoidable. If fractions are unavoidable, well, there's nothing you can do about it, right? But here it's avoidable. So now to make this 2 0, now here's the new leading entry, right? To make this 2 0, I'm going to multiply the second row by -2 and add it to the third row. So then what we are going to get is 1 0 -3 8. So all there is now multiplication 0 1 5 -2. So -2 plus 2 is 0. 5 times -2 is -10 plus 15 is 5. -2 times -2 is 4. 4 plus -9 is -5. Okay, so now we have the row echelon form. Okay, because row echelon form means, okay, if there is an entire 0 row, that should be on the bottom. We don't have such thing here. The second condition is that the leading entries should be to the right of the previous one. So if we mark the leading entries, they are moving in the right direction, right? Okay, they are to the right of previous leading entries, and under leading entries in that column you should have zeros. You should have this triangle of zeros on the bottom. Okay, we have this triangle of zeros on the bottom, right, under the diagonal. That's the row echelon form. Now I am gonna go ahead and get the reduced row echelon form. What is reduced row echelon form? Reduced row echelon form means you have these leading entries. They should be 1. They should be 1. No other number, 1. And everything else, okay, in the each column should be 0. Okay, leading entry should be 1, and in that column everything else should be 0. So here what I'm gonna do is I'm going to make those leading entries 1. Now this is already 1. This is already 1. So 5 is the only one that we need to change. What can we do? Well, divide by 5, right? R3 divide by 5. So here division is unavoidable. So we must do it. See, 1 0 -3 8 0 1 5 -2. Here 0 0 1 divide by 5 and then -1. Okay, all the leading entries are 1. Then the only thing that's left is we need to make everything else 0 in columns. Okay, in columns of leading entries. So here it's 0 except the leading entry. That's good. Here except the leading entry, everything else in the column is 0. But here leading entry here is 1, but these two are not 0. So we want to make those two 0. How can we do that? Well, to make 5 0, I'm going to multiply the third row by -5. Right, -5 third row plus add it to the second row, right? So then we are gonna get 1 0 -3 8 0 1. So this is going to be 0, but -1 times -5 is 5. 5 plus -2 is 3. 0 0 1, and we need to make this -3 0. What can we do? Well, we can multiply the third row by -3 and add it to the first row, right? So then it's going to be 1 0 0. Oh, multiply by 3, right? Third row we have to multiply by 3 because we have already -3 here. -3 plus 3 is the 0, right? So we multiply the third row by 3. That's enough. So then the right hand side is, so here it's -1. So -1 multiplied by 3 is -3. So -3 plus 8 is 5. So that's 5. Okay. Now 0 1 0 0 0 1, here 3 and -1. There we go. Now we have the reduced row echelon form. Row echelon form. Now we have the reduced row echelon form. So from here, finding the solution is super easy. So if you write this as an equation, now this is coefficient of x1. Coefficient of x1 is what? The right hand side is 5. Everything else is 0. x2, this one means x2. x2 is what? Right hand side is 3. This one means x3. Coefficient of x3. x3 is -1. There we go. We get the solution. We have a unique solution. Okay, now the important thing is try to see the difference between the echelon, row echelon form and the reduced row echelon form. Okay, so reduced row echelon form is much simpler. Like I said in the previous video, zeros, a triangle of 0, like here a triangle of 0 from above and a triangle of 0 from below, and in the diagonal you have 1. Okay, right, but in the row echelon form it's pretty flexible. Okay, except that you want this 0 triangle of 0 below the diagonal. Okay, that's in simple words. All right, okay, so this is an example where a solution exists, a unique solution exists, but things get little bit different when there's no solution or when there's infinitely many solutions, especially when we get this row echelon and reduced row echelon forms. We'll see that in the next 2 videos. I'm going to do a video where an example of a no solution case, and then a video of example of an infinitely many solution case, and then afterwards I will do a video for many examples. Okay, all right, I'll see you in the next video.